Hey everybody, welcome to my channel. My name is Stefano and today I have a pretty cool project for you guys. We're going to see how Google Maps and pretty much all those applications work under the hood with Dijkstra's algorithm. This is a graph or database and this is the application that we're going to create. But first, let's pick a definition. Let's look for a definition of Dijkstra's algorithm. So I think the first step for this tutorial is we need to have a clear understanding of what's Dijkstra's algorithm, right? So we're going to do the smart thing and we're going to go to Google or DuckDuckGo and find the definition. So yes, and I'm going to read the definition for you guys so we all can learn here together. So Dijkstra's algorithm, as you guys can see, is an algorithm for finding the shortest path between nodes in a graph, which may represent road networks. It was conceived by the computer science Dijkstra. I have no idea how you pronounce the name, I'm sorry, in 1956, and it was published 3 years later. So yes, as you guys see, let's check some images. The definition is pretty clear. It's an algorithm to find a recipe to find the shortest path between point A and point B. It's what most of modern map applications like Google Maps, Apple Maps use under the hood to take you from destination A to destination B, pretty much it. So let me go back here. This is a representation. This is gonna be this is gonna be a representation of our database. I did this representation so you guys have a clear understanding of what we're doing here. We are gonna be working with nodes. No, these are the nodes and these are the edges. Okay, so we're gonna be using cities, so it's easy for us, and this is it. This is it, right? So this is the application, and I'm gonna show you right now a pretty quick test of how everything works. So let's say that we want to travel from Paris, so which is the first city right here, to Madrid. So Madrid, and we calculate the shortest path. We call our algorithm, and it's gonna show you, it's gonna change color in the tiles first of all, and it's gonna show you the path right here. So for traveling, we have to go from Paris to Rome and to Madrid. Now let's check that in the graph. See, so you guys can check I'm not lying and I'm not a liar. So the Paris, this is the Paris node. It has to travel from Rome and then it has to travel to Madrid, which is this one right here. It could go from over here to Miami, to London, to Sydney, to Jerusalem, to Istanbul. So pretty much go all the way around to the graph, but the algorithm is smart enough to find and figure out the shortest path. Okay, let me do another test before we start the tutorial. So I'm going to travel from Istanbul to Istanbul is right here in the map. I can find it. It's this one right here. So let's travel to Miami. Istanbul to Miami, which seems a little far. So yes, so as you guys see in our application, it has to travel from Madrid, Rome, Paris, and Miami final. And Miami is the last destination. So let's check that in the graph right here. So from Istanbul, it goes from Madrid, then it goes to Rome, and it goes to Paris, and then it goes to Miami. You could say that I would go from Madrid to Dubai to Toronto, Quito, and then Miami, but we're going to define the distance in each node, and that's gonna be shown in our database, and I'll show you when we create the database. Okay, so I guess this is pretty much for the demonstration. Don't forget to like and subscribe if you enjoy and if you like and if you find this tutorial useful. And I think that's it. Let's start the tutorial. So the first step that we're going to do, we're going to open the terminal, and I'm going to navigate to the desktop, and I'm going to create my project there. So I'm going to type cd desktop, and we're going to name our project. Wait, first, before creating the project, I'm just going to create a folder so we can store everything there, and it's everything more organized, because as you guys can see, I have a lot of stuff in my desktop. So I'm going to type make dir, which is the command to make folder. We're going to name it YouTube tutorial. Okay, and it's this folder right here. So let's just navigate to the folder really quick. And once we are inside the folder, we are going to start. And right here, I'm going to create another folder, and this one is going to be the one that's going to hold our project. So I'm going to call it Dijkstra API. Let's see, Dijkstra API. I'm going to click ls to make sure that we have created our folder. It's right here. So let's navigate inside. I'm just going to copy and paste because it's a little hard to type Dijkstra, as you guys see. Let's see. Okay, so now that we are inside here, we're going to create our TypeScript project. Okay, we're going to, as I said in the beginning of the tutorial, we're going to use TypeScript, and we're going to use expressjs to create our API. And yep, let's just do it. So we're going to type npm init and y to make everything just faster. Let's wait, and now we're going to install our dependencies before we open the project in the VS Code. So we're going to need a couple of dependencies. We're going to need npm install. So we're going to use express. We're going to use mongoose. We're going to use the body parser for JSONs. We're going to use TypeScript as well. TypeScript. I just want to make sure I type everything right. So no typos. TS node for TypeScript is going to be another package that we're going to use. We need to use the types for Express and for Mongoose as well. Okay, so types Express, and then we're going to use the types for Mongoose. So let me just make sure I don't have any typos, guys, because that's a little annoying. npm, I think everything's right. So let's just click enter and let's wait for our packages to install. In the meantime, we can just navigate to VS Code, and now we're going to open our project. Just want to make sure first everything is installing. Don't worry, I'm going to just speed this part. Yep, everything's correct. Let's go here, and we're going to open our folder. If I remember correctly, we left it here. So now we have to look for the folder. I know my desktop is a mess. I have to clean everything. YouTube tutorial is this one right here. Okay, so yes, this is our project. We have our modules, and this is our package, the JSON. We have to make a few modifications here. Since we're using TypeScript by convention, we're going to create the source folder. So every piece of code that we have in TypeScript is going to be here. And yeah. Now I'm going to go to our source folder, and inside here I'm going to create our entry point for the project. So it's going to be index.ts. So now that we're finished here, I'm going to go back to my package JSON, and I want to make a few modifications so we can run our project and configure everything up. All right, so this part we're going to delete. We're going to get rid of this test, and we're going to replace it for a build. And inside here, we're going to replace this part for a TSC. This is going to be used to just compile everything. So now we're going to have a few more. We're going to have a start. And inside here, we're going to type node, and we're going to put everything in a dist folder, and no, this is index.js. All right, so once we start our project, the project is going to look for the dist folder, which is going to hold all our compiled JavaScript files. Okay, we're going to type one more, which is going to be for NodeMon. I think I forgot to install NodeMon, so I'm going to type NodeMon and source, and it's going to have the index.ts. Yes, because it's better to use NodeMon for development. It's easier. We're going to use seed, and I will show you in a few seconds what we're going to use this for. So basically, we're just going to use this seed command to feed our database data. All right, so we don't have to waste time, creating the data one by one. We're just going to do it fast. So I'm going to type dist and seed.js. This is where everything is going to be here after we compiled. All right, and one more, we're going to need our TS here, and I think I'm just forgetting a comma, and I think this is ready. Let's just save everything. Okay guys, so now that we are done here, let's go back to our index.ts, and I'm going to just really quick create our server. So I'm going to, I'm going to import Express from Express. We're going to import Express from Express, and we're going to create the app. So I'm going to create the app from our Express server. The app is going to run in the port 3000. So now below here, we're going to type app, the listen. We're going to listen to our port. We're just going to put this variable port here. Let's create an anonymous function and open the function here. We're going to console log to make sure we are running the server, and we can see everything in the terminal. And here we're going to open backticks, and we're going to type server is running import, and then we're just going to import the port, which that sounds funny, right? So import the port here. And yep. Okay guys, so now that we're finished here in our index.ts, I'm going to save the file, and I'm going to go back to our file tree, and we need to create one more document, which is for TypeScript. We're going to create our tsconfig JSON. So we need to create this document in order to use TypeScript in our Express server, okay? So it's going to be name config.json, this type right here, and I'm going to just copy and paste the configuration. Don't forget that I have everything in my GitHub repository, so you guys don't have to waste time typing this one by one. You can just copy and paste. I'm going to save the document. I'm going to go back to my Express, and I'm going to open my terminal, and inside here we're going to first we have to compile our TypeScript to normal JavaScript, and then we're going to run our project, okay? And then we can continue to install the database and to create our Dijkstra algorithm. All right, so I'm going to type npm run build. We have to wait until the compilation is ready, and we're going to create this folder. As you guys see in the file tree, if I open this folder, we just have plain JavaScript. That's it. That's pretty much it. So I'm just going to close this, and I'm going to run the project to see what happens. So in order to run the project, we just have to type node. We have to go to this folder, remember, and we have to type this.js. And we have a problem. Let's see what happened here. Oh yes, oops, my bad. I type app.js because in this case I use index.js. I'm sorry about that. It's my own fault. So let me just retype the command, and I'm going to retype index.js. And as you guys can see, the server is running on the port 3000, which is pretty cool. So let's just continue. I'm going to leave the server open. So the next step is we're going to create our database, and we're going to feed our database with the graph that I showed you in the beginning. So I'll show you how to do that really quick and very easy. So in the source folder, to keep our code organized, I'm going to create another file, and I'm going to name it db.ts. And this is the file where our mongoose is going to be, or mongoose package. So I'm going to import mongoose from mongoose, and inside here you can type mongoose. We have to type connect, and here is where we are going to put the link for connecting our database, pretty much. So, and I think that's pretty much it. And I think we have to export, if I remember correctly, we have to export default and the mongoose connection, right? Yes, and we're going to save. I'm going to go to my browser, and we're going to create our database. So this is my MongoDB account. So you guys see I have a couple of projects. So I'm going to go to new project. I'm going to name these Dijkstra's YouTube project. So I'm going to type next. We are going to type create project. Let me just expand this so you guys can see a full visual of my browser. And now we are going to create the project, right? So go to database in here in the file tree from the website. Go to build database. We're going to use the free version, no need to pay in this case. Here I'm going to use my password. I'm going to type 1, 2, 3, 4, 5, 6. Please remember this password, because this is the password that you are going to use in order to connect it to the project. I'm going to type create user. The password is too weak, so I'm going to type YouTube 12 / let's see if this one works. This one works. And inside here, I'm going to type 0.0.0, which means the database is going to be accessible from anywhere. I'm going to use just that in order, I could use my own IP address, but sometimes I have problems with my own IP. So in order to avoid any troubles and the tutorial to be more smooth, I'm going to just enable the access from anywhere. And don't worry, I'm going to delete this project as soon as it's posted in YouTube, so you can hack my account. So I'm going to add the entry. Once we have added the entry, I think that's pretty much it. So yes, the project is created, the user is created, and we have established the IP address which will access our database. Now you have to go to database here. The project is loading in the meantime, so you have to go here and connect. You're going to go, this is the different options that show you that you can connect from the shell. We're going to use VS Code. Click this, and this is the link that we're going to use. Click the link, go back to VS Code. If I can find my VS Code, I think I didn't minimize. It's right here, and you guys are going to copy and paste this here. Usually you would use, Usually you would hide this, but this is not the purpose of this tutorial. I'm just going to do it really quick, and I can't remember the password. I think it was YouTube 12 / yes. Okay, so I think that's pretty much it for the database. Now we have to go back to our index and import this configuration. Then close this file so everything is more organized. I'm gonna close this, and this. So before I forget, I'm going to import another thing. I'm going to import body parser, because we need to use this in order to use JSON in our project. So I'm pretty sure I'm gonna forget if I don't do it now. So I'm going to put the body parser here, and then you have to put JSON. All right. So that's it, and inside here we have to wrap our app listen function with our db once connect. Oops, and I have to import everything, or db file. So I'm going to import dv from, and I think it's this one. I'm going to put the semicolon to be consistent, and below here I'm going to type dv the once. We're going to type open here. We're going to put a comma and then anonymous function. We're going to open and close the anonymous function. We're going to put a semicolon and just cut this part right here, copy and paste, and then put it inside. Save everything. I'm going to close my project, and I think that would be it. Let's see. Let me clear everything, and let's run the project and hope this is working. And yes, I think the project is working. Otherwise, we would have an error here. So yes, let's continue. We're going to create an interface for our document or our database, and we're going to create a schema for Mongoose package, all right? And I'm going to do everything in a different file to keep everything organized. I'm going to name this document or file City, because we're using City as a demonstration for this tutorial. And inside here, I'm going to import a couple of things. The first thing is Mongoose, and next to Mongoose, we need one more thing, which is document. Oops. So inside here, type document, and we also need the schema. So now we have to create our interface, all right? Make sure you export the interface, type interface, and then we're going to call it iCity, all right? City, and it's going to extend document, okay? So we're going to give it a name. The name is going to be a string. We're going to have neighbors as well, neighbors. And the neighbors are going to have an object inside, which is going to have a string, and it's also going to have a distance, all right? And distance, which is going to be a number. Now that we're done with our interface, we have to create our schema. So we're going to name it city schema, and we're going to type new, we're going to type mongoose, we're going to call our schema, and inside the schema is going to be for the city. All right, so the schema is going to be for the city. We're going to open it. We're going to have our first value, which is going to be the name, and it's going to be a string. I think it's just a comma. And now we're going to have our neighbors, right? And as you guys saw, it already knows that and its neighbors, since we're using city interface here. So yeah, the computer is pretty smart about that. So we're going to open the brackets. We're going to create an object inside, and here we're going to type a string, which is a name, and we also need the distance, which is going to be a number. All right, distance is right here. I think it's number, yes, it's with capitals. I'm going to put a comma here. I'm going to put a semicolon right here, and we also have to create the city here, a constant for city, and it's going to be our model. All right, so mongoose, you have to call model. We have to put our city here, close this bar, open parentheses, and inside I want you to type city, all right, which is going to be the name of the model, and inside here just put the schema, and after that we just have to export the city. All right, so we're going to call export default and the city. All right, hope that wasn't a little confused. I know I talk a lot, so I'm going to save the document, and we're going to go to, no, we don't have to go anywhere. Now we have to create our data. All right, so I'm going to go to the source folder, and I'm going to create a document which is going to be seed.ts. So inside here we are going to import our city. All right, yes, I think it's from the correct location, and we're going to import our database as well. So here I'm going to open our database. So call the database, call once, type open inside, and this has to be an asynchronous function because we're going to feed our database right here. I'll show you how we do that. We're going to await, we're going to call our city, and then we're going to click delete many. This is going to be for updating our database in case we call this more than once. And below here, I have to type await. We're going to click city, and here we're going to insert many, which is going to insert our values, which I'll show you in a second. And just insert the cities here, and I just wanna see in case the operation is successful. So we're going to console log, and I'm going to type example data inserted, example data inserted, if I can spell, inserted, and I'm going to put a semicolon here, and then we're going to call process and this exit. All right. And yes, so now you may be wondering what's the data that we're going to insert. So we just have to we're going to insert an array full of cities. All right, so let's create the array. Is going to be named cities. We're going to open and close it. Right now, Typescript is screaming because we're passing an empty array. If it's empty, it's of class any. So I'm going to just copy and paste the values that we're going to insert, and the error disappears. So I'm going to just expand these so you guys have a better visual, and oops, I think it's control equal. All right, and now in a few seconds, so this is the data. In a few seconds we are going to insert this data. So I'm just going to walk you through it really quick. As you guys see, it's just an array of objects, and this is the Paris node, this is the Rome node, this is the London, this is the Miami, this is the Madrid, this is the Tokyo, Sydney, we have Quito, Istanbul, Dubai, Jerusalem, Toronto. So 12 nodes. As you guys see, let me just go back here, are the same nodes. This is a representation, as I showed you in the beginning of the tutorial, this is a representation of the database, and these are the actual values, all right, with the distances from each node. So let's just save the document. Let me open the file tree one more time. Let me make this a little smaller so it's better for me. I'm going to open the terminal. I'm going to, I don't have to close the server. I'm just going to do this right here. going to click ls to make sure I'm in the correct location, and I'm going to click npm run. Oops, before I forget, see, I was about to make a mistake. So every time that you work in TypeScript, I'm going to stop the server. You have to compile everything, because if I seed the data, if I put the data in the database, the document, the computer is going to look in this folder dist, and I currently don't have anything. I just have my first compile, which I did in the beginning of the tutorial. So first we have to compile, and then we have to insert our data in the database. All right, so for compiling, we have to click npm run build. Just click everything. We have to wait for 1 second. And as you see, everything expanded. Now we have all the data that we need. Now we can click or type npm run seed, and the example data has been inserted. So as I show you, that was the purpose. Just created an extra command for us to be able to see the data easily. So I'm going to close this package JSON, and I'm going to go back to our database, which is right here, and let's see if everything works. So now that we're here, I'm going to go to browse collections to check if everything has been inserted in the database. And yes, as you guys see, we have our 12 objects here. We have the object Paris, Rome, London, Miami, Madrid, Tokyo, between the others. Let me open if we have the neighbors, if we have the other objects. So yes, these are the edges, these are the nodes, everything is ready. So I'm going to minimize this. I'm not gonna minimize, I'm just going to go here, and we can go back to our index.ts. And the next step that we are going to do, we are going to work in the hardest and more exciting part of the tutorial. We are going to create the Dijkstra algorithm, and I'm going to do everything in a different file to keep everything organized. As you guys already know, we have to keep our code clean. So I'm going to type dijkstra's.ts. Okay guys, so now that we create the file dijkstra's.ts, we're going to do our first step. The first thing that we need is we need an interface, since we're working with TypeScript. So I'm going to call an interface called neighbors. So I'm going to type neighbors right here, and I'm going to do a capital neighbors, and I'm going to open square brackets, and I'm going to name the name, or the name is going to be a string, which is going to be a type number. Okay, so that's pretty much it for that. The next step that we're going to do is that we're going to create the function. I'm going to export the default function right here, type function. I'm going to call it Dijkstra, and I'm going to open parentheses and close square brackets. The first thing that you guys need to know is that the function is going to return a string, a list of strings, I'm sorry. And I'm going to put a return here so we don't forget that later. And we're gonna have 3 parameters. The first one is going to be the graph that we're going to receive. The next one is going to be the start point. So I'm going to put the start point right here. And the next one is going to be the end point. That's it. So the start point and the end point are going to be strings. We're just going to pass strings, and I'll show you. We're going to test this algorithm in a second using Postman. And the graph is going to be of type record, which comes from TypeScript, and it's going to be a string and also our neighbor. So neighbors right here. So yes, that's the beginning of the function of our algorithm. And our function, I'm gonna try to be as clear as possible here, because this is like the main part of the tutorial, and I'm going to try to break down step by step the function. So we need to start with the initialization of everything. All right, we're going to initialize 20 objects and 1 empty list for our queue. So the first one is going to, let's create a constant which is gonna be called distances. And these distances is going to be of type records string number, and it's going to be an empty object. All right, so let me just type this really quick, and I'll show you what is this for in a second. So string number, let me close, and it's going to be an object, and this is going to be a record keeping track of the shortest distance from the start node to each node. All right, we need to keep track of every single node right here. We're going to create a very similar before or after that, I'm sorry. So it's going to be called previous, if I can spell previous, and it's also going to be of type record. Let me type everything here and I'll show you and I'll tell you what is this for in 1 second. And it's gonna be either a string or null. This can be null, that's the difference. And it's also gonna be an empty object. Okay, and this is gonna be a record keeping track of the previous node on the node to the shortest path to each node. Okay, so the next one and the last one, of course, is gonna be our queue, and this queue is pretty self-explanatory, and this one is gonna be an array containing all the nodes to be processed. Okay, so if any node hasn't been processed yet, is on the queue. The next step is that we're going to initialize the distances and the previous distances. All right, so for that we're going to create a for loop that will loop through each node in the graph. All right, so let me create a for loop and then I'll explain step by step what everything is for. So we're going to create the for loop, and it's going to have a constant which are going to name vertex. We're going to name vertex, and in graph, because we're looping our graph. Okay, we open square brackets, and the first thing that we have to check is if the vertex is at the start. So I'm going to check. Let me just write this and I'll explain in a second. We're going to put our distances, our vertex, which is going to be 0, and we're going to call our queue, click and shift. So now that I'm done here, I'm going to explain this really quick. So what we're doing here is that we're checking if the node is in the start node. We are going to set the distance to 0, and then we're going to add it at the front of the queue, and we're going to call our queue and unshift it, meaning the front of the queue is the end part of the queue. That's why we use the unshift method. All right, it's pretty explanatory. We're gonna have a else condition, and we're going to check otherwise. We're gonna set the distance to infinity and add it at the end of the queue. All right, meaning at the beginning of the queue. So we're going to call our distances, we're going to put our vertex here, and we're going to put infinity, and we're going to put a semicolon right here. We're gonna call our queue, and we're going to push it, all right, at the beginning of the queue, so the end of the queue. It's a little confusing, but yeah. So we're going to put the vertex, and we're going to set each node after our if statement. We have to set each node as null for each node. All right, so we have to call our previous, we have to call vertex, and we have to put null. So the next step that we are going to do is we have to process all the nodes in the queue. So we have to first check. We are going to create a while loop, because if there's no nodes in the queue, there's no nodes to be processed. So we have to check if the queue has a length. So we're going to call our queue, we're going to put a length, and we're going to check if it's bigger than 0, meaning we have nodes to be processed. Now we have to select the node with the smallest distance. All right, so I'm going to type the code, and then I'm gonna explain what the code is for. Okay, so we have to create a constant to select the shortest vertex, or shortest distance. So shortest vertex, that's how I'm gonna call this variable, and we're going to call the queue, because we have to sort everything. We have to sort everything by the distances. All right, so in a typical sort method, we have to call AB here. It's going to be an anonymous function. We have to call our distances. We have to put A here, and we have to subtract it by B. Distances and B, and then we have to call our shift, all right, to push it. Now we are going to create a for loop. We're going to create a variable here, which are going to call neighbor, and we're going to loop in our graph. And here we can insert our shortest vertex, which has been sorted. We can open square brackets, and here we have to create a distance variable constant. We have to put our graph, we have to put our shortest vertex, and we also are going to insert our neighbor that we are just looping. Okay, and inside here we are going to create another constant, which we are gonna call distance alt, and we're going to put our distances right here, and we are going to inject our shortest vertex, and we are going to add our distance. Okay, so the variable, the constant that we just create. So what we're doing here basically is that we have to sort the nodes in the queue based on their distances, and this is the first step that we are doing right here. And then we are going to select the node with the smallest distance as the shortest vertex. That's what we are doing right here, and we are injecting the shortest vertex that we selected before and we sorted in the graph. That's the reason for this for loop. Okay, so moving on, we're going to check for each neighbor in the shortest vertex to calculate the potential to the new distance to the shortest vertex. So let me write the code and then I'll explain later. Okay, after here, I'm going to create an if statement, and we are going to check our variable alt, see if this one is smaller than our distances, and we have to inject our neighbor. Okay, we're going to color square brackets, and here we have to color distances, and we are going to inject our neighbor, and this is going to be equal to our alt. Okay, and below here we have to color previous, and we have to inject our neighbor one more time, and then this is going to be equal to our shortest vertex. So what we're doing basically here is a relaxation. For each neighbor in the shortest vertex, calculate the potential to a new distance, and if the new distance is smaller, what we're doing here, we're checking that if statement. If the new distance is smaller than the record distance, in the distances record that we keep right here, we're going to update the distances and the previous node. And finally, we have to backtrack to find the shortest path. Okay, so once the algorithm is done, it has to backtrack using the previous record to find the shortest path. So how do we do that? We're going to call a new constant. We're going to create a new constant called path, and it's going to be of type string list. And have to initialize this right here, so it's going to be an empty list to start, and then we're going to create another constant, which is going to be a let constant, and it's going to be same. We're going to have either a string or a null, which is going to be equal to our end. Okay, so here we have to check. We have to do a while loop, and we have to open parentheses and check while the current it's current. We have to color path. We are going to unshift everything, not everything. We have to unshift our current, and then we have to put a semicolon here, and then this current is going to be equal to our previous. And for finalizing the algorithm, we just have to return our path. So to explain this, I know I went a little fast here. We have to, once the algorithm is done, like I told you, we have to backtrack to the previous record to find the shortest path. So we have to start from the end right here, from the end node, and keep following to the previous node until you reach the start node, and adding each node to the path array. So once we reach that start node, we have to add every node to the path array, and that would be the answer. And then we return the shortest path, which is what we have left, right? So I think that was it with the algorithm. I'm going to check really quick if we don't have any mistakes, and I'm going to save everything. This algorithm can be highly improved through other optimizations, like using a priority queue instead of sorting for the queue each time like we are doing here. And that would be used in a real world implementation, okay? And we also can include an error handling in cases that are not covered in this basic example. Okay guys, so now that we're done with our algorithm, let's go back to our index.js, and we have to do our final step, which is to handle the routes for our algorithm. We are going to have just two routes. I'm going to have one that will display, that will bring all the cities, get all the cities, and another one to post to calculate the path. So the first one is going to be used in our front end. That will be the second part of the tutorial. So first we have to create a synchronous function, and we're going to call our request and response params, as you guys are used to that. So we have to create a try and catch. Let me put an enter here. We have to put a catch, and we have an error. I'm going to oops, I'm going to finish this part first. I'm going to console log if anything happens. Hopefully nothing will happen and everything will work. We're gonna have an error fetching series, and I have to put the error right here so we can see it in the terminal. And I'm going to send a status response, all right? So to make it a little bit more pro, it's going to be a 500, so a server error, and we're going to send a JSON to the front end, all right? And the error is going to be failed to fetch the series, right? Just keep it simple. Fail to fetch, oops, I can't spell fetch the series. Okay, so as for the try part, we just have to grab everything in a constant, which is going to be called series. And here we have to await, we have to call our city, and we just have to call our database, right? So the method is find in Mongoose. We have to find, which is going to bring all of them, and we're going to put the response in a JSON object and send it to the front end, and that's pretty much it. So JSON and series, all right? So we are sending all our response as JSON to the front end, and I think that's it for the first route. So we have to import our Dijkstra's algorithm. So Dijkstra's, and I think that's all of the imports that we need. So that was it for the first route. Let's create the next route, which is going to be called calculated path. So app is going to be a post request. We have to put a slash here, and we're going to name it calculate path. It's going to be an asynchronous function as well. We have a shortcut for this. We have to put a request and our response. And for this first step, we are going to be expecting two things. Remember, the start city, and the end city, right? So we want the algorithm to show us the shortest path between these two cities, right? So this is gonna be come from the request body, right? Request body. And yes, so that's the first part. So now we have to fetch all the cities and build the graph. So how do we do that? The first step is that we have to fetch all the cities, and then we have to create the graph with those cities, all right? So we have to create a constant, which is gonna be called cities right here, and it's gonna be of type iCity. We already have the class created, which is gonna be an array of iCities, to be more clear. And we have to await the response. We have to call our city, and just as before, we have to find, which is gonna bring all the records that we have in our database. So now we have to create the graph here, and it's gonna be of type record. Here, let me see if I can spell that. Record, and it's gonna be a string neighbor, all right? String and neighbor. And now that I remember, we don't have neighbor. I think I didn't export. I'm just gonna create this neighbor one more time here. In a project, you would just have your own file here, your own private file with the types. I'm not gonna do that. I just wanna do this really quick. Name, if I remember correctly, it was a string, and it was a type number. Yes, so neighbors. So now that we have it accessible here, and it's gonna be, our graph is gonna be empty by default. Okay, so next we have to just loop through everything. So select the cities, and we're going to, for each city, let me put a city here and open the square brackets. And here we have to iterate over each city in the cities array fetch from the database. And for each city, create a property in the graph object in the city's name and the key, and an empty object as the value. Then we have to iterate over the city's neighbor, adding each neighbor name and distance to the corresponding graph entry. Okay, let me show you how do we do that. So we have to select our graph. We have to put our city name, which is gonna be empty for now. Then we have to select our city, the neighbor, neighbors right here, and then we have to loop again. So for each, we have to put a neighbor here, neighbor. We have to open square brackets, and now we have to call our graph. We put our city name, city then name, and then we have to put our city then, I think it's neighbor the name as well, right? Neighbor the name, because we need the city and we need the neighbors too. So that's gonna be equal to the neighbor distance. All right, so the neighbor the distance, okay. And next we have to create a constant called shortest path, and this is gonna be used to just calculate the Dijkstra function. We're gonna pass the Dijkstra function here, we're gonna pass the graph, and then it's going to return the JSON object with the shortest path. So here we have to call our Dijkstra function, Dijkstra function. We have to pass the graph as we created before, the start city that comes from our request body and our end city, right? And as the last step, we just have to send everything as JSON, right? So JSON, and I think it's an object like this, if I remember correctly, the syntax. And yes, I think that's pretty much it. Let me put a semicolon here to be consistent. And beautiful. I think we are done with the route, with the post route. Let me see if everything's working correctly. Our server appears to be working fine, so I think that we are ready to go to Postman and test everything. We're running on port 3000. So let me just go to my database to see if everything's working. Just have the I always have to refresh everything and see if everything's working, so I don't have any ugly surprises. Yeah, I think everything's good. Let me open Postman, which I opened before, and here I'm going to, let's test the first endpoint first. Cities, yeah, if I remember correctly, cities is a get. So let's send the response. And I think we have a problem here, and I'm pretty sure I know which is the problem, but I wanna know if you guys can figure out what's the problem. So just think about for 1 second. We're working with TypeScript, all right? So we saved the document, we create our routes, our algorithm, but we never compile our TypeScript into JavaScript. And that's something that will happen to a lot of us since we're working with, I'm used to working with Node.js and Express, but with JavaScript. So let me just go back here. I'm going to stop the server and I'm going to compile everything so we can use our code, right? So npm run build, I think it's run build, and let's compile our TypeScript code, right? Let's wait for 1 second. As you see, or the document on our dist file increase. So let me just close it. We don't want to see that. And then let's start our server one more time. So let's just wait until it connects to mongodb. We have to wait for 1 second. So yes, I think now that everything's connected, it should work. So let me go back to Postman and hopefully this works. Otherwise, we're gonna have to debug this fucker. And let's see, we're going to first test or get a route, right? So let's send a request, and it's a 200 request, okay? Let me see how can I check everything. And as you guys see, we are fetching everything from our database. We have our first object, which is Perry, the neighbors. We have London, Rome, Miami. We have the other object or other node, whatever you want to call it, which have Paris, Madrid, Tokyo. Let me, I want to show you the graph that I created for you. So we have a visual representation for now until we create the front end. And this is it, right? So as you guys see, let me just go to the first node. So Paris is the first node, right? And in the neighbors array, we have Rome, which is the first neighbor. And yep, Rome. We have London. London is right here, it's connected to Paris. And we also have Miami and Miami. So yes, this is the visual. This JSON object is pretty much this graph, which is pretty cool in my opinion. And let me just minimize this, and now we have to test our second endpoint and most important endpoint. Okay, I'm going to open a new tab here. This is going to be a post request. Let me just copy and paste everything. Copy and paste I have here because I already tested in my other application. It's going to be a row. Remember, you have to send everything as JSON. Now we have to open square brackets, and our first endpoint is going to be called star city. And our second endpoint, give me 1 second, is going to be called end city. And city. Okay. So now what we want to send, right? So let me pull out the graph one more time. Let me minimize the graph here so we can see everything. So the first thing that we want to test is we want to test I already tested. I'm going to test Miami. So I'm going to put Miami as my star city, and I want to travel to, if I want to travel to Jerusalem, what's going to be the shortest path to go from here, from Miami to Jerusalem? As you see in the graph, we have a couple of options. We could go from Quito, Toronto, Dubai, Tokyo, Rome, or just make a shortcut here, or go to the left from London, Sydney, and Jerusalem, which I think that's the answer. That's the shortest path. I'm not really sure. So let me type Jerusalem, no spaces, and let's send the data. And yeah, we have a shortest path, and let's check. And yeah, I was right. So the shortest path from Miami to Jerusalem is, it goes first step here, Miami, then it goes to London, it goes to Sydney, and it goes to Jerusalem. So pretty cool. Let's test another endpoint. Let me go to Paris. That's gonna be our first, and we want to go to Dubai. Let's send a request, and the shortest path is from Paris. We have to go through Rome, go through Madrid, and go through Dubai. Yeah, you may think that Tokyo is shortest, but if we check, let me go to our database. If we check, we have actual distances. You could use, let me expand this bar. For each neighbor, we have the distance, and this distance is the equivalent to meters or miles, whatever you want to use. So I'm pretty sure the distance between this one, where's the graph? Right here. Between the distance between Paris and between Madrid and Tokyo, this one is shortest than this one. In the graph, it looks the other way around, but it's not. Where it counts is what's in the data in our database. Okay, so just wanted to make that clear. Okay guys, so now for the second part of the tutorial, we're going to be working on the front end of the application, and we're gonna use Flutter to display our data from the backend. So really quick, I'm going to go to my terminal, and as I remember correctly, I'm just going to navigate one step to the back. I'm gonna check that Dijkstra's API is my backend, so I'm going to create a Flutter application. So Flutter create, and I'm just gonna name it frontend, like this. We just have to wait until the project creates, and that's it. I'm going to minimize. I'm going to open my new VS Code window, and I'm gonna open the project there. All right, and we're going to create the front end. So we have a full-on application, okay, with Dijkstra's algorithm. Yep, it's this one right here. So let's open the project. I'm going to open the Linux folder, the lib folder. Yeah, this is it. And I'm going to run our project here to make sure everything's working. We're going to use an iPhone 14 simulator to simulate everything. Let me just clean these comments. There you go. And we can start debugging everything. So I'm going to skip the tutorial until this is loaded. So see you then. Okay guys, so now that we have our uploaded in our simulator, I'm going to clean our project really quick because I don't want to waste time in here. And I'm going to just put a text widget here for now. Okay, so yeah, everything seems to be working fine. I'm going to create a new screen. So this is gonna be our screen list. I'm going to name it screen list.dart, and it's gonna be a stateful widget. Okay, so this one, oops, I think I got it wrong. This one, stateful. So let's name it city list screen. Okay, city list screen. Okay, I'm going to import the material art here. I think we are going to use the scaffold. So scaffold, save the document. Let's go back to our main.dart, and instead of this text widget, let's just import our city list screen, and I think it's not going to be a constant for now. And yes, so everything here is ready, so we can see our changes. Now I'm gonna create one more document, because before working in our screen, I wanna get over the functions. So I'm gonna call fetch data.dart. Okay, and this is we're going to put our documents here where we are going to just call our backend. Okay, for that, now that I remember, we have to use one package which is called HTTP, and we have to install it first. So I'm going to, in Mac, Command Shift P, add dependency, and we're going to call HTTP. All right, it's that easy. We just have to wait until the extension is ready, and okay, I think that's it. So I'm going to create a future. That's going to be the first, and which is going to be expecting a list of strings. And we're going to call it calculate the shortest path. Okay, calculate shortest path, if I can spell correctly. And yep, it's going to be an asynchronous function. City is going to be the first param, and the second one is going to be end city, string and city, like this. Let me expand this so you guys have a full visual. Let me put the square brackets here, and we are going to have our response. I can spell today clearly. Response, and we're going to await the response, and here we have to call our HTTP package, and it's gonna be a post request, of course. Let me see if I can bring my HTTP package so we don't get this ugly error. Apparently I can. I think import package. Let's see how it's HTTP. Is this one right here, http.dart. And let's call it as HTTP, like this. And yeah, the error disappears. All right, so as convention, we have to click URA.parse. Let's see if I can find it. I can find it. So URA.parse, and inside here is where we are going to put our link. So if I remember correctly, in Postman we already have it, so why type it one more time? Why repeat ourselves? So let's copy and paste. Let's minimize Postman one more time, copy and paste here. I think this is it. I just have to, oops, I think I'm missing a semicolon here, so let's do it so we can refactor. Okay, it's just screaming that, I was just checking, this is just screaming that we have to return something. We will in 1 second. The program is rushing us a little bit. So headers, we need headers, so headers are gonna be 2 strings, a string and a string. And yep, and here inside here we have to put the content type, type. If you're familiar with working with APIs and all that stuff, you're familiar with doing this. Application JSON, which I think everything works. Everything's like this, right? Yep. Let me know in the comments if I'm wrong. So yeah, so here, and for the body, we are going to have our JSON. We have to first encode the response. So inside square brackets, we have star city. That's how we call it in the, this has to match what we call it in our backend. So star city, it's gonna be star city and comma and our end city and city is gonna be your end city. And yep, that's pretty much it. So now let's handle the responses. All right, so we're gonna check if we have a 200 response. So if we have a response which is the status code equal to 200, we are going to have a final decoded response, which is gonna be a JSON decoded response. So let's put the response and the body, right? We need a semicolon here, so everything refactors. Sorry, we need a return, which is a list right of strings, list of string, which comes from decoded response, and shortest path. Okay, so else we're gonna have, or else we're gonna throw an exception, and here we're gonna fail to calculate the shortest path, right? Fail response, just to keep it simple. All right, so yes, that's it for calling our function. We just have to trigger our function in the backend. We don't have to do anything fancy, and handle the 200 response, which comes to our response is just a JSON object, and handle the exception, which is an error. And I think that's it. So now we need to create another function, which is the one that's gonna fetch all the cities, which is gonna be very similar. So it's gonna be a future as well, future type list, which is gonna be a string of dynamic. Okay, string dynamic. Here we're gonna call it fetch all cities. We're gonna call these, we're gonna have a synchronous function. So now we're gonna have, just as before, a final response. We're gonna wait our HTTP, and this time is gonna be a get. It's not gonna be client, it's gonna be a get method, which is gonna have a URI parse and our endpoint, which is our endpoint this time. Let's go back to Postman again, and I think it's this one. This is our endpoint. Copy and paste, minimize Postman one more time, and copy and paste. Okay, so now let's just handle our response. So let's check if we have a 200 response, the status code, which is equal to 200, open square brackets, and we're gonna return the list of map string dynamic. Okay, so return list of map. If I'm always get confused in this part, string dynamic, close it, which comes from, if I'm correct, I think I'm having a typo here. Help me find the typo. Okay, I think it's this, from JSON.decode, right? JSON decoder, no, it's decoder decode, and we have to put a response.body. All right, we have to put a semicolon here, and let's just do the exception. Else, put this, and we can just copy and paste this exception right here, and save the document. And yeah, that was it. That's our two functions to call our backend. So we can go back to the file tree, and we are going to work in our screen. All right, so since this is a stateful widget, we're gonna need two things, okay, to encapsulate our cities and our shortest path. So we're gonna need, just as before when we did the algorithm, we need a cities empty list and a shortest path set empty object to store everything. Okay, so I'm gonna have a list, map, I think it's a string dynamic, if I remember correctly. It can be null, so cities, and it's gonna be a list. Okay, so this is the first one, and the second one is gonna be a set of strings we're gonna call a shortest path set. Okay, shortest path set. We have to override our init method. Let's see, init state is this one. Okay, and we are going to create another method here. I'm going to show, we could do everything inside here, but let's keep it clean. So to load the series, so I'm gonna have a future which is not gonna return anything, so it's gonna have a void as a return, and we're gonna have loaded series, right? Load series. Close our method is gonna be asynchronous, of course, and open this, and this method we're gonna call it here. So what are we gonna have here? So first we have to call their series, right? So loaded. So we have to call our function that we created before. So let's create a final loaded series variable, cities, which is gonna be equal to a weight, and what we are going to call all our series, all right? So fetch all series. So that's it. So now we have to call our set state method, and we're gonna have a series, which is gonna be equal to our loaded series, all right? So we're gonna call this variable b right now. I'm calling it series here. We could just use loaded series, but just to make it more clear, I guess. So yes, so below here, we need to create another future, which is gonna be a void return, no return anything, and we're gonna calculate the path here, okay? Calculate the path. And we're gonna have expecting or string start city, and another string, which is the end city, all right? Oops, and city. It's gonna be, I think, synchronous function. Yes, it's a synchronous function. Let me close the file tree so you guys can have a better visual. I will say that. Let's have a try and catch. Let's put the error here, and the error, let's print it so we can debug in case anything happen. Error. Let me make it a little cleaner, and I think it's this is the syntax. Yeah. Okay, I think it's like this. Yeah, it's a little different in Dart. I get confused with JavaScript. So now we're gonna have the path, okay? So this path is gonna come from the await and calculate our method, right? Calculate shortest path. We inject the variables or the params that we're gonna expect, and we're gonna print everything in order to debug again, all right? So I'm going to just put path here, and I'm gonna have a shortest path comment here, so I know everything, where everything comes from. Okay, so below here we have to set the state again, all right? We have to set the path. Set state, we're gonna have a variable here, shortest path set, and it's gonna be equal to set from the path. Now we can work on our scaffold, okay? So the first thing that we are going to do is going to work on our body. We're just gonna need the body, and we're gonna check if everything's null. So because we're working with data from the internet, so you always want to do that. So if the data is not null, we're gonna have a padding, and this padding is gonna have child. Oops. Let me put the padding first. So constant, it's edge index, the old, we're gonna have a padding of 28. These values, I already tested these values, so I know what I'm doing here. You can pick whatever value you want. So I'm gonna have a column here. Open the column, open the children, and we're gonna have a size box first, cons size box. and this size box is gonna have a height of 30. Okay, let's see what else we have. So before that, if the series is null, we check. This is what we are gonna show if the series is if we have series. I'm sorry, and if we don't have series, let's just show a circular progress indicator. That's how it's called, circular progress indicator, like this. Okay. So yes, this is our list screen. Now we have to create another widget, the widget to calculate the path button, because we're gonna have a button in the front end that's gonna calculate the path, the shortest path. So I'm gonna create that widget in another file. I'm gonna go here, I'm gonna go to live, and I'm going to calculate, just create a calculate path button. The dart. Okay guys, so in this screen we're gonna have another stateful widget. So let's create the stateful widget, and we're gonna name it calculate path button. So calculate path button. Okay, let me import the stateful, so the material, the dart here, and yep, this is pretty much it. So let's work first in the UI, and as we need the next things, we're gonna work on them. All right, so here we're gonna have a size box. Okay, size box, and inside this size box we're gonna have a height of 800 pixels, and as a child we're gonna have a column. This column is gonna have children, and these children, let me hide the file tree so we have more space, and we're gonna have the children. Okay, so first we're gonna have a row, and we're gonna have our buttons or text fields, I guess, here, right? So row with children, and we're gonna have expanded widget. Let me put this expanded widget here. We're gonna have a child, and first a text field. Okay, text field. Let me save if everything's working. I think everything's working right. I think I have to, in order to see the changes in the screen, we have to import to our screen list or calculate path button. We're just gonna do that in 1 second, okay? So first, in here in our text field, we're gonna need a controller, and this controller is gonna be a star city controller. Okay, we're gonna have a star city and an end city controller to insert these values. So let me just skip this for 1 second, and we're gonna have a const text, no, it's input decoration, I'm sorry, input decoration, and we're gonna have a label, and that's it. That's pretty much it. And we're gonna have start city label text. I think it's label text, and start city, and we can duplicate this text field. So how do I duplicate this text field? So from this expanded, so here, right here, let me copy and paste like this, and we're gonna have a size box. Okay, size box, and a width of how much? Of 10, just width of 10. Okay, so now we are going to create our text fields. So we're gonna go back up here, and we're gonna have a text editing controller, and it's gonna be a start city controller, which is gonna be equal to text editing controller, right? So let's copy and paste, and we're gonna just name it. All right, change the name, copy and paste this right here, and copy and paste it here. Copy the end city controller, Control C, and Control B. Okay guys, so moving on, we're gonna copy and paste this size box, and below here, if I'm correct, I think it has to be below below this part right here. So below the row, we're gonna have a size box, and here we're gonna start working in our button. So the elevated button, let's make an empty function for now, and here let me just put a text widget, text widget here, and we're gonna have calculate shortest path. Okay, calculate shortest path. Okay, so I think it's time that we start working. We need to work on our function. All right, so we are gonna come up here. Okay, so now from here, this is gonna be an asynchronous function because we're just gonna call everything directly from here. I'm gonna have a try and catch block here, try and catch, and I'm gonna put the error first. I'm gonna print the error in case we have unexpected situations, error, and let me put the error right here. Okay, so let me make a space so we can differentiate, and right here we're gonna have a final path which is gonna be equal to a wait, since we're doing a synchronous function, and calculate the shortest path. And inside here, what do we have to put? The controllers, right? So star city, the controller or the text, and here and city the text. It's a semicolon here to refactor the code, and we have to set the state after that, and the shortest path is gonna be equal to our path. So now we have to create this list above. Okay, so let me just go up here, and below these controllers, I'm gonna have a list of strings, and this is gonna be our shortest path. It's gonna be an empty shortest path equal list. Okay, I think I'm spelling it correctly. Shortest path. Let me just make sure. All right, yes, everything is spelled correctly. And I think before I forget, we're also gonna need a series empty list. Okay, so let me put list map string dynamic. Okay, and this is gonna be our cities. This can be null, so let me put this right here, and this is gonna be our cities. All right, and we also are gonna need our set. Okay, so a set for the shortest path, so it's a set of strings, and this is gonna be our shortest path. Let's call it set, since we already have a path. Okay, so below here, guys, we have to call our init method, and we have to do pretty much what we did before in our list screen. So I'm going to come up here, I'm going to copy and paste this method, and I'm going to paste it right below here. So yes, I think that's pretty much it. And we have to do one more step right here, okay? Because this widget is going to ask for our function, our calculate function that we create here. So we have to pass it. We have to pass this function, the result of this function, to this widget. So how do we do that? So if you're familiar with Flutter, you know you can do that from the widgets. All right, so we have to call our future and make it a require widget. So void, which is not going to return anything, just the result. So future void, and it's going to be a function, and it's going to have a string as a param, two strings, and yes, and it's gonna be called calculate function. And we have to make this require. So let's put a require this calculate function, and I think it's like this. All right, so we can save this document for now, but let's finish the widget. So below here we have to check if our shortest path is not empty, so we can display the result in the screen. So if it's not empty, we're gonna check and put a text widget, which is gonna say shortest path, and we're going to just insert the result here. So inside here we have to say insert the shortest path here. We're going to join, and then we are going to put this kind of arrow so we can see the result. We're gonna have arrows in between our result, okay? So we can see it's better, it's a better visual. So yeah, that's what I mean. So otherwise we're gonna have a constant, and we're gonna have a size box that shrink, okay? So no, nothing. Size box, that's pretty much it. So below here we're gonna have, I'm going to decorate I'm gonna have some tiles that are gonna change color when we have a path, okay? I'm gonna display all of them, all the cities, and whenever we select some cities, they're gonna change color, as you saw in the beginning of the tutorial. So here's where we're gonna put our widget. So let me put a text widget in the meantime. Here, text. And so we can go back to our list screen, and below our size box we can call our calculate path. So we are over this part, calculate path button, and we have to pass our function, right? So our calculate path, this function right here. So yes, I guess we're gonna be able to see our buttons. See, as you guys see on screen, we can see everything. So let me go back to calculate path button, and we have to create 2 more widgets. All right, so let me open the file, and I'm going to create the first one. It's going to be a city card, and then the city graph, which is going to be a grid builder, right? So the city card dot is going to be this one. And I know I'm working a little fast, but I don't want the video to be too long, so this can just be a stateless widget. So city card, let me import the material, the package, and here we can just, I think container, nope, it's a car. A car is better. So let me make a car here, and we're gonna have a color that's gonna change. All right, so the color changeable, we can make it here. So car color, we're gonna have east. Oh, so we have to pass. So I guess we're gonna have to pass these, okay? So pass this string city name. Of course, we have to pass the city name, and we also have to pass the color. So it's gonna be a boolean that's gonna check whether it's selected in the path, okay? So is in shortest path, let me put those right here. This the city name, and this the short. I think I have to make this a require, and this is also have to be a required. Okay, so let me make this a little smaller, and we can start checking. All right, so we're gonna have is in shortest path. We're gonna have a colors the green, okay? Otherwise we're gonna have red, colors the red, and let me put this as a color. And I think I'm missing a semicolon right here. And yes, we're gonna have a child, which is gonna be a list tile, and this list tile is gonna have a title. I think it's a title, right? Yes, title, and the title is gonna be a text widget, which is gonna have the city name, and we're gonna have a style. Let's just style it a little bit. Style, and it's gonna have a text style. Color is gonna be colors the white. The font size is gonna be 14, and we're gonna have a font weight doubled. Okay guys, so we can save, and this is it for our card. So let me go back to our file tree, and we're gonna create a graph, okay? So city, the graph, the dart, and this is gonna be a stateless widget as well. So city. Let me put this city, stateless widget first, and city graph. Let me import the material, and here, okay, so here we're gonna need a grid view builder, which is gonna have a grid delegate, and we can take care of that before. So first we also have to, just as we did in our card, we have to pass these values, not these values, I guess. I think we have to pass the city name and the shortest path set, right? So we're gonna have a final list of string, and it's gonna be city names. Let me just put this correctly, and we're gonna have another final list of string, and it's gonna be shortest path set. Okay, shortest path set. Now I'm not gonna make this a constant. All right, so let me get rid of this part. We have to call the city name, and this the shortest path. Okay, so now we can take care of our grid builder. So our silver is gonna be a silver delegate grid builder. Silver, I think, is this one, and the cross axis count is gonna be 3. Yep. Now we need an item count, and the item count is gonna be city names the length. We're gonna have an item builder lastly, and the item builder takes in a function, this context. I think it needs context and the index, and the index is that one right there, but I'm not gonna trust that shit anymore. So yes, so we're gonna have a final city name, which is gonna be equal to city name index. Okay, so we need to pass the index right here, and then we're gonna have a final is shortest path, which is gonna come from is shortest path set. We are going to check if it contains the city name. Easy like that. City names. Okay, so if everything is correct, we're gonna have to return our city car widget and then pass the values. Okay, and I think we are good to go here. We get to save it, and now we have to export the city graph to our calculate path button. So here, instead of this text widget, let's just import city graph. Let me see if I can find it. It's this one right here, and we needed 2 values. Okay, so the first one is the shortest path, no the path set, just the shortest path, and the next one, the city names, are gonna come from our cities that we're loading right here from our from this function that comes from our init. So every time that we rebuild the widget, so I'm going to just do a map really quick. So we're gonna have cities. We're gonna make sure this is not null, because we're already checking if everything's null in the screen before this one, and we're gonna have a city that's gonna loop through city name. Okay, so the city name, and it's gonna be as a string, and then we'll have to convert this to list, I think. Yes, and we have to put this with semicolons, and yes. Let me save everything. Now I think that we're done, so let me just check all the screens that we have created. Let me see. My main screen is the list screen. This is the next one, and this one calls the calculate path button. the calculate path button calls the graph city, and the graph city calls the car, and these are our two functions. So I think we have to just refactor everything to see our values in the screen. Let me close the application, and I'm going to run the application one more time, and it should work. Okay guys, so now that we have reinitialized the application, you guys see the app is fully working. So I'm going to open my browser really quick, and hold on, because I want to see the database, the graph database. So this is our representation, again, a representation of our database, and let's test the application. So I'm going to call Paris if we want to travel from Paris to let's Rome. Let's keep it simple. And as you see, the tiles change colors, and we have a visual, so it's pretty cool. So from Paris to Rome, and I also have this line here that show me the path. Okay, so let's see again from Paris to Tokyo. And you have to make sure that you spell it right, otherwise it's not gonna work. So from Paris to Tokyo, you have to go from Paris, Rome, and Tokyo. So let's pick another one, another star city. Let's pick Dubai to Tokyo, for example. And from Dubai to Tokyo, the two of them are connected. Let's check that in the graph. Where is Dubai and Tokyo? As you see in the graph, the two of them are connected. So you can verify everything here. So let me pick Miami to Quito, and we're gonna calculate the shortest path. And as you see in the graph, the two of them are connected, so the two of them just need one hop to travel from one to the other. Okay, so I'm gonna do one more. So I'm gonna make sure I pick one that it's far. So Rome from Quito, I guess, or Jerusalem. Quito, let's pick, or Sydney. So let's check. So from Rome to Sydney, it has to go this way: Paris, London, and Sydney. So it has to go this way. It could go from Madrid, Istanbul, Jerusalem, or it could go from here in the middle, crossing Tokyo, Dubai, Toronto, but it picks the shortest path, which is the purpose of our algorithm. And for today, we are done. That was the tutorial. It was a pretty cool tutorial, and I hope this is very useful for you. This can be used as a project for your resume. It's a great project. Thank you so much for your time. If you made it to the end of the tutorial, thank you so much for watching. Don't forget to subscribe and like this video if you enjoy it, and have a great day. Bye bye.